Okay, I have started the recording and let me share the screen as well. Okay, I think the screen has been shared, and if there is any problem in sharing or anything, then please let me know. Okay, so today I am going to start. I'm going to discuss one important topic, that is how data science is related with IoT, and as a data scientist, how we should approach towards a given data. So what I'll do, I'll I'll discuss about some IoT and data science relation, and then using some data set, I'm going to build a complete model from scratch. And in the meantime, I'll also teach you some basic stuff of pandas, which you must know before processing your data. So I have shared my screen, and let me start with the PPT. Okay. I hope the screen is shared and it is visible. And if there is any problem, then please let me know. And bit size of screen I have also increased. Okay, so let's start. Why data science and IoT goes hand in hand. So everybody know what is IoT, and almost everybody know what is data science. Superficially, of course, if not in deep. So what makes a smart world is collaboration of Internet of Things and artificial intelligence. And what makes artificial intelligence successful is use of sensors. Now, these sensors, what they do, they senses the data, send it to some cloud. That cloud can be near you, that is called edge computing or fog computing, or it can be in some adverse distance condition, that is called cloud computing. The servers are stored in cloud somewhere far, not in our reach, or it can be within our reach, that is fog computing or edge computing, where further data processing can take place, making machine models more accurate in predicting result. Now, if you see machine learning, deep learning, they are all subsets of artificial intelligence. And there is one thing that is common when you see that set diagram, you all have seen that a circle, that is called artificial intelligence, another circle within it, that is called machine learning, and another circle within it, that is called deep learning. Now, what is the common in between these three things is data. And how first thing, how a data scientist got the data. So that data is generally obtained from surveys, different kind of surveys, or these sensors. What they do, they senses the data, they send it to some cloud, some server, and there that data is sent to certain data scientists for further processing. Why these processings are required? Because we don't want unnecessary data to be fed to our machines. We want our machines to make them more intelligent, more accurate in taking decisions. And that's why we process our data before feeding them to the machine models. We'll see that in later. And according to survey by IHS, by the end of 2020, which is end now, there will be 31 billion IoT devices in market. And by the end of 2030, this number will reach up to 127 billions. Now, you can imagine with that much amount of IoT, how much amount of sensors are required and how much those sensors will send the data to the cloud. And that's why this data science and data scientists are so important. These devices are pushing data to the cloud at an annual compound growth rate of 27.6%, and that's a lots and lots of data. It means that every year the data which is being sent by these sensors are only going to increase, and that too at a compound growth rate of 27.6%. Hence, data analysis is one major important factor which governs the success of machine learning, which further ensure the success of artificial intelligence component and IoT. Moving on, let me check here. Okay, I think I'm clear. Okay, talking about basic IoT stuff, starting with some simple sensor application. I need Arduino. I'm talking about only a simple sensor application, how I can build a simple sensor application without much involving complex instruments, complex hardwares, and complex programming as well. So what I need, this is a gas sensor. This is normal a gas sensor. You can take it as a smoke sensor also. This is a Node MCU, and this is an Arduino board. Now, using these three components, I can make one simple sensor application. Let's check this thing here. Okay, if you see this, I've just incorporated the gas sensor with Arduino at pin number 0, analog input pin 0. And here you can see a small code is written in Arduino, which is not Python code, obviously. And all these codes are readily available in internet. So what happens with this code? Now, this code will read analog input at pin 0, and it will send that smoke sensor data to some cloud. How it will send to the cloud? Using this Node MCU. So I've written some code here. This code is available on internet, nothing new. You can see that now, if we ignore this Node MCU, thing, and if we look only at this thing, then this is not IoT. This is simple sensor network. IoT involves internet. Now here, no internet connection is done. This is sensor. I have written some program for it, burn it in IoT, and this Arduino connected this pin, and it's just sensing the smoke or sensing the gas. But when I involve internet, then it becomes IoT, because now with the help of internet, I want to control this thing from some distant location, and for that Node MCU is required. For that, here you can see here HTTP connection is required. Now this is what is the problem with this code or with this type of connection, that this connection is not secure, because I'm using port number 80 here, which is not HTTPS, this is HTTP. So talking about data integrity, this network is not secure. And one more thing, you can do these type of things without involving Python. So what is the need of Python? This is simple embedded C type of programming written in Arduino. And what is the need of Python? That as I already told you, when sensors collect the data and send it to cloud, there you need to do the data analysis. And why data analysis is needed? Not for artificial intelligence, but for machine learning, which is a subset of artificial intelligence. So there comes the role of data analysis. And for data analysis, there are certain tools. There are certain platforms like R, Scala, Python, and many more. I prefer Python over other for different reasons. Python is obviously easy to learn. Now there comes the advantages of Python, which everyone knows. Like if you want to do statistical analysis, I prefer R. But other than that, for better visualization of data analysis, overall data scraping from internet, I prefer Python because of its inbuilt libraries, which are readily available, and very good forums, helping forums. So this code, I send it to ThinkSpeak, and you see here. Now what is happening? Data sent to ThinkSpeak. You can see here the message. Gas level is 26.59. Let me just zoom it a little bit. You can see here, I think. Yeah. And then gas level is 26.39. Actually, it's changing. Actually, what I'm doing, I was just blowing on that gas sensor because I was not using some matchstick, lighter, or candlestick or fire. It is a gas, so what I did, I just blow on that CO2 level. And now what is happening? This is the screen of Arduino, virtual screen, LCD, virtual LCD, and my account is on ThinkSpeak. Their data is being sent, and from there it is just showing the output. So now it has become IoT because I have involved Node MCU there. So let me start with some data analysis part. Now you have understand why data analysis is needed, not for IoT, but much for machine learning, which makes IoT. So here is a question. I have got two sets of bananas here, as you can see, and I want to show you how actually, in theory, this machine learning thing works. Now, what I need to do, I need to check whether the banana is raw or it is ripe. So how machine learning model is treated or fed with data. Suppose I take this data, this is my input value, this is a ripe banana. I'll fed it to machine learning model, and then machine learning will decide according to its size, length, color, and everything, and then it will predict the output. And how it will learn, that is the data which data scientist will provide to it. So stopping here, I'll go to the file. I'll start with a Jupyter file that I have created here, and I'll just show you. Any question? Let me check. Okay. So what I'm going to do, I'm going to start with the Jupyter file, and I use Anaconda package. So here, what I am doing, let me show you something. I have got a file here, folder here, files for HTTP name, in which I have saved all my work. And then when I'll open my Jupyter notebook, then I need to go to this file here where all my work has been done. And from here, new, I will click on this Python 3 file, and it will open here, something like this. This is actually untitled, so I have named it. You can rename your file from here. Some basic stuff, I have renamed it. So here it is. Now what I'm going to do, I am going to show you if, like a data scientist, a data has been arrived to me from the sensors. So before processing that data for machine learning, what I show you, machine model here. So what I need to do, I need to fed my data to this machine model. So before feeding my data to this machine model, I need to process my data. And for processing those data, general purpose languages like C, C++ won't help. For that, you can use R, you can use Python. So for that, I'm using Python. And for that, I'm using one library that is called pandas. So my first line will be, I need to import this library. So I will write import pandas as PD. And let me just zoom it more. Okay, I think now it will be more clear. So it will be import pandas as PD. And let me just give you a brief introduction about pandas. Pandas is a word which has been derived from statistics, that is called panel distribution. And in statistics and economics, panel distribution means multi-dimensional tabular data. So from that, the name pandas has been derived. And in Wikipedia, you can read the name of pandas as Python Data Analysis Library. That is also called pandas. And import pandas as PD is nothing but an alias. Alias, like you are calling pandas as PD. So whenever you need to write pandas, you will write PD. And in fact, you can write any name here. Just pandas is more universal accepted name, so we use that. Okay. So let me, the first thing which I always prefer to do is to check the version, and for that, so this is the latest version that I'm using. This is 1.1.3, and this is the latest version of Panda available in Anaconda package. And how you can install Anaconda? So in Google, you have to write Anaconda individual edition. Go to this individual edition. Just click on that, and it will let you to reach this page. Just scroll down to the bottom, and here you see whatever platform you are using: Windows, Mac, Linux, 64-bit, 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 and you can see for Linux and Mac now 32-bit version support has been disabled. So for Windows, still 32-bit graphical installer is there. Just install it and just click on like next, 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 and it will get installed. So I am using this. This is the latest version, and that is 1.1.3. And you just need to follow this. I'll provide this file, or I'll not ask you to just type with me because I don't know which version you are using. Maybe the things which are running here will not run on your system. So I'll just ask you to just see and see the things which are going here. So the first thing is PD version. So this is 1.1.3. Above this, it is 1.0 point something. And there are certain things which will run on that. And there are certain things which are not going to run on older version. And that's why I have used this version to teach you, because this is the latest version. After that, I need to check which version of Python I'm using. So for that, you need to write from platform import Python version, Python underscore version, and then you need to write print Python version as a method. Now for method, you need to just put empty braces here after Python underscore version, and when you run it, so it will show you it is using 3.8.5. Now one important thing, don't get confused with this version. This is the version that Anaconda has provided with this Jupyter Notebook. This is not the version which is installed in your computer, or suppose you are using 3.7, or suppose you are using 3.9 or 3.8. So this version is provided by Pandas or Anaconda, you can say. This is not the version which you may be using on your computer or desktop personally. Okay. Next thing, there are certain modules. Why I prefer Pandas also, there is one more reason. There are certain modules, like you must have heard the name NumPy, Matplotlib, Seaborn, etc. If you are using some other IDE, if you are using some other IDEs, say Idle or Sublime, or in fact Python or Atom, anything, then you need to install these libraries individually. With Pandas or with Anaconda, approximately 150 such type of libraries are automatically included. Like if you write here import NumPy, and if you run this, then see no error will occur. NumPy has already been installed, has already been provided with Anaconda package. But if you are using any other IDE, you need to install this NumPy also using pip install NumPy and so on. So this is NumPy. And again, you can give some alias name. So import NumPy as NP. And how I have to run this, let me show you. I am just putting here my cursor. There are two and three ways to run this. Import NumPy as NP, click on run, and this is the sixth cell. These are called cells. So this cell is running import NumPy. Another thing, just place your cursor here, and what I am doing, I am using shift and enter from keyboard. So shift enter. So this is one way. And now if you use shift enter and if you run this, then automatically it will move on to the next cell. See here, shift enter, it moved on to the next cell. And there is one more thing you can do, control enter. Now when you do the control enter, then also it will run, but it will not jump onto the next cell. So these are something basics. And how you can check the version of NumPy. So just write np double underscore version, and okay, sorry, version spelling. So this is 1.19.2, and this is also the most updated version of NumPy that we are using. Uh, so if you want to check what matplotlib version it is going, so how you have to see matplotlib, just write this, import matplotlib, and then print matplotlib dot double underscore version. So let's see. 3.3.1. Now, I haven't installed these things individually. They all are provided with Anaconda package. This is one advantage of using packages. So this is how you can check the versions. So moving on, let's see. Now let's use some data now. Let's have some data. So what I'll do the data here. Data is equal to how to access the data, how to bring the data here that my sensors have sent to the cloud. Okay, now what is happening? I'm using some IoT device. Some sensors are gathering some data and they're sending that data to cloud. And from there, suppose I am data scientist, the data is being sent to me in form of Excel file or CSV file or some any other file. And my boss wants me to process the data so that that processed data can be further used to build some machine learning model. So first thing, how to fetch that data here on this Pandas or Jupyter screen. So I'll use pd dot read underscore CSV file. So if my file is CSV, then I'll write pd dot read underscore CSV. And here, just put the bracket, and here you can see cursor is glowing. If you press here, shift and tab. So you see, if you press here shift and tab, shift plus tab, you can see the features and characteristics of this CSV file. So here it is showing like, see, pd read underscore CSV. Now what I need to do here, I need to put the file path or buffer. So let me put the file path here. So there are three ways with which you can call your file here. Now what I'm using a file called advertising.csv. Okay, let me first check whether it is data. Okay, so what I am using a file advertising.csv. Now that's why I showed you where I am working. I am working in this files for HTTP folder, which is on desktop, and my advertising.csv file should be placed in this folder if I am calling my file this way. Okay, now there are two different ways with which you can call this. One, if you know the URL of this file, like if you have account on GitHub or Google Drive or some cloud operating server, then directly you can paste the URL here, then also it will work. Or if your file is in some other location, let me show you. If the file, where it is, this is advertising, let me copy and paste it in somewhere else. Suppose my file is in D drive, it is not in the working folder, then what I need to do, I just need to copy. So let me copy, it is D. Okay, I'll just paste it here. Let's see if it's working. It is. Okay, so here it is, and if I run this, I expect to work. Okay, so it's working. Okay. Now, if so, these are three ways. If you had been using, okay, let me check here if some issues. Okay, I think everything is fine. Um, so, if you are using older version of pandas, then this will throw an error. The error will be that this backslash will be treated as an escape character. In that case, you just need to put here two slashes, two backslashes. Okay. Now this is the latest version, so it is supporting this thing. So you need to understand this thing. Uh, just remove this thing. No problem. Okay. Uh, I show you. You can use Shift Tab. One more thing. You can whatever the link you are pasting here, whether it is of your local machine like D dot, or whether it is some URL or like this CSV file, you can place your cursor here and you can use Shift Tab also. So what it is showing, you can just click the plus button here and you can see what are the different parameters this CSV file is using. There is a separated delimiter, header, names, index column, none. Now these none, none, false, false, these all are default values, and according to my need, we can change it. And we will see just now. So here, if you just scroll down, now here it is written sep equal to string and it is a default. Default value is comma. It means that the CSV file, which is known as comma separated value, I don't need to paste here as sep equal to comma, because by default it is like this only. But suppose it was a TSV file, like TSV means tab separated value. Then what I need to do here, I need to press here T. It means that I need to change my default value of comma to backslash T, which means TSV file or tab separated value. So just let's, okay. One more thing. Okay, just overview of this data. You can see here there are 1, 2, 3, 4, 5 columns and some 200 rows and 5 columns. This is the Excel. This is the CSV sheet. Now this is one of my favorite CSV file, and I'll share this with you in the group later. Uh, let's see what we can do with this data first. What I check usually. So let me check what we need to check. The variable name is okay, data. So let's see, data dot columns. Shift enter. I'm using shift plus enter to run my cell, not this every time I need to go there. And so data dot columns, what will be it will do? It will provide you with all the columns name. Data underscore columns. So if you see here, these are the columns name: TV, radio, newspaper, cells, unnamed. Okay. Similarly, data dot values. So data dot value will provide with an array of 2 dimensions. There are 2 square bracket. It means that it is a 2-dimensional data, and it will provide with you the individual row values. So there are 200 rows, and if you scroll it down, so if you see, there are 200 row value data. So data.columns is used to check the data column names, and data.values will provide with individual row data. And using data.values, let me check if I can access a specific data. Okay, so this will data.values, and in square bracket 0, I can use the individual data also, means only one row. So in Python, you know, in list, everything starts with 0. So I can write data.values 0. It will give me the first data. Similarly, -1 is the last data. So this is the 200 data, and it will give me the 200 data. Let's check some more things. Data dot shape. It will provide with the shape. So it is a 200 cross 5 matrix where 200 rows are there and 5 columns are there. Similarly, data dot size. Data.size will provide with the complete data size. 200 into 5,000 data sets are there. Okay. Moving on, there are some more important things. Data.info, which is one of the most important functions. Info with bracket. It is a method, data.info. And as a data scientist, this is one of the most important things which you need to check. So see here, this will give you a summary type of thing. There are 200 entries starting from 0 going to 199. It is a data frame. Now what is a data frame? Data frame, there are two things, data series and data frame. Data frame is simply more than single dimension data. If the data is a single dimension or 1D data, then it is known as data series. So there are 5 columns, and you can see these are non-null values. There are no zeros in each column. There are no zeros present in each column. Data type is integer, float, float, float. So there are two types of data type, float 64, int 64, and the memory usage it is using is 7.9 kilobytes. So this info method is very important. What is the difference between a method and function to write? If you use this empty parenthesis, then it is called a method. And if you write this as normal without parenthesis, then it is a function. Suppose I put here a bracket, then it will throw an error that tuple object is not callable. So if you remember, tuple is something which is written within normal parenthesis. So this is normal parenthesis. Okay. Moving on, let's see what we have got. Okay, there is one more thing that is called data.index. What it will do, it will provide me the index of my table. So it is starting from 0, stopping at 200, and it is just incrementing by 1. So this is, if you see here also, this is 0, this is 1, this is 2, 3, 4, 5, and so on. It's going on, moving on. Now, this is a very small data set. This is a very small data set of 200 rows and 5 columns. But if there are more, there are some 1,000 rows, then it is always good to check the top 5 rows. Top 5 rows, and it will be written as data.head. By default, it will give you top 5 values. And you can even pass how many numbers you want to check. Suppose you want to see top 10 values, then you can see top 10. Now this top 10 means in increasing order it is top 10. I haven't sorted it in top 10 or any type of thing. It is just top 10 values from starting. So data.head is used to see that by default first 5 values, and I can pass the numbers up to which I want to see the values. Similarly, sometimes it is needed to see the last 5 values. Then by default is a data.tail, and see it. So this will give you the last 5 values, data.tail. And now the last number is 199 because it is starting from 0. So there are 200 values, data.tail. And like head, I can also pass the user defined value up to which I want to see. So these are the last 10 values of my data set. So these are important things. Now talking about columns, suppose I want to see a specific column, then what I'll do, there are 2 ways. Data in square bracket, you can write the column name. Like there is one column name TV. So data is the variable name, and I'm writing data square bracket in quotes TV, and it will provide me the TV column values. Another thing, another way to write this is data dot TV. Let's check if it's working. Okay, it's working. So this is called dot notation, and this is just bracket notation. So I generally use this thing data.tv because now let me show you one more thing. Data 1. Let me just put it. Data 1 is equal to say what I can say here. Data one. I just want to pass the TV name here, and then I want to train data one. Okay, so this has been just I have assigned this to a variable data one. Now, if I want to check the type of this data one, that is important. Train type of data one. So this has become a series. Okay, so class series. Now, what is the advantage of this series? Why I use this notation? Because if you know basics of Python of strings, then what happens now? You can use data.tv, .replace, .adds types of functions in continuation. This is what happens when you are working with series. Now you can use multiple operation in series actually. So I prefer this function, but if there is a need to change like this thing, then you can also use this thing. So let's check one more thing. Data.dtype. This will provide the okay, data type. Some error. Data frame object has no attribute data type. Let me check here. Okay, it is data types. Okay. So this will provide you the individual column here. Let me just. It will provide with you all columns and their data types. So data.data types, and if you see the data type overall is object. I'll later tell you tomorrow what this object thing is in detail, because this is a very conceptual thing, and it is readily asked in interviews also. So this object data type is very difficult thing to deal with. Okay, so how to drop columns? There are conditions. There are some things. Certain time you need to drop your column. So let's see how to drop the column. So what data for dropping a column or removing a column? We will use data drop, and then in bracket, in parenthesis, just type the column name which you want to drop. Suppose I want to drop the TV column. Then okay, what is that? TV not found in access. Okay, okay. I need to put here access also. Access means by default pandas will drop the row, and I need to drop the columns. So I am writing columns in quotes, and when I run this, so now if you see the TV column has been dropped. The TV column has been dropped. And in fact, one more important thing is here. If I write data again, see here. So this thing is not permanent. If you want to do this permanent, then there are two ways. You need to assign this thing back to data, which I'm not going to do right now. I'm just showing you. Just drop it and assign it back to the data variable. Or there is one more thing what you can do. Again, if you comma and shift tab, so if you see here, let me just plus. There is one word in place equal to false. So by default, this in place equal to false. If I write here in place equal to true, which means that I am just uh, saying pandas to just in place this thing true to the original data set. So drop TV and put it in true condition back to the data variable. So there are two ways. Again, I'm not doing this because I don't want to drop the data yet. So this dropping is temporary if you are not assigning it back or if you are not placing it in true condition. So this thing you have to remember. And in fact, you can also drop multiple columns, like if you want to drop multiple columns here. So if you see here now, TV and radio both are gone. And again, access.columns is new feature of pandas. Maybe it won't work in the earlier versions. In earlier versions, what actually happens, we used to write 1 for column, okay, access equal to 1 for column, and access equal to 0 for rows. Okay, so this is one important thing which is new in pandas. In you can write columns. Now, yeah, writing the name is more readable, and it won't create any confusion. So this is more useful. Okay, so moving on. Now what I do, there are two more important things which we need to know before processing our data. You must have heard it if you have involved in any sort of data science element, that is called lock and ilock. So let's just see what this lock and ilock look like. I'll write data.ilock, and then in bracket I need to pass the index position, not in normal bracket, but in a square bracket. Actually, this is index location. Ilock is index location, and I am subsetting it. I am using two square brackets, and I need to find out 0, 1, and -1 values. So this is 0th index position, this is first index position, this is 200, or -1 means the last index position. So ilock will give you index position values, whatever number you pass in its parameter. Now you just remember you have to pass two square bracket, because what it is doing, it is a subset, and in that subset I am just checking the index position of these values in the list, 0, 1, and -1. So this is how data.ilock, data means this is the variable name, .ilock function works. Talking about lock, let's see how lock works. Data.lock, and I need to pass, lock is a location, so I need to pass 0, 1, and it will throw an error, unhashable type list. In lock, we don't pass index number. In fact, we pass the name. So let me write the name here, TV, and see if it works. Okay. So it is showing unhashable type list. Let's check. Okay. So none of index TV are in the index. Actually, what is happening? The thing is that this new pandas don't support log function like this. So now what you need, 0, 1, and -1, and in place of numbers you need to just write the name of columns which you want to see. Lock is used to pass like that, number of rows and all that. So what I have to do now, how this lock function works, let me show you how this lock function works now. In new pandas, you need to pass it in a variable first. What things you want to see and what things you want to drop. So let me write this thing here. Okay, let me write data1 is equal to the columns which I want to see. So I want to see PV, and I want to see, I want to see the radio. So this is the first thing that I need to do. Then I need to pass this to some other variable, say filtered data. filtered data. Now this filtered data is my actual data dot. Now what I'm doing, I am changing the index. So I'm re-indexing it. I only want to see TV and radio. So I have to re-index it. This re-index is the new feature. Do remember that this new Anaconda will not support lock function. If you want to use the lock function, if you have to use this in this way, data dot re-index, and then which columns you want to see. Columns, I want to see the columns of data 1, and let's filter this thing, filtered data. So this is how it works. This is the newest feature of pandas. They have removed the log feature, and now using re-index you can use the alternative of log function here. Okay. So as a data scientist, these are the basic things which we need to analyze before jumping into the actual machine learning. So let's jump into the machine learning thing now. I hope it is all clear and there is no problem. If there is any query, you can unmute and ask at this point, or we can jump. Okay, so just recall the things which we saw here. IoT is based on artificial intelligence, which is further based on the use of maximum amount of sensors. These sensors are responsible for collecting data. Collecting data means it is sensing data. We are collecting that data, sending it to some cloud server. Their data is getting collected and it is then sent to some data scientist or data analyst for further analysis. And that cleaned processed data is then used to model our machine. So I showed you in this, like I need to analyze using this machine learning whether this banana belongs to the ripe category or raw category. So what I need to do, I need to train my model. Okay, this is just like training. I am training my model with with some input values. I am giving it a raw banana, I am giving it ripe banana of different shape, different length, different colors, and then this machine is getting learned. And how I am sending this machine, whether it is raw, it is ripe, what color it is, that is all in form of some Excel sheet or CSV file. Means it is in some form of data. So this machine is learning through this data and then analyzing this thing. And always remember, the output of machine is predicted. So maybe it is 90%, maybe it is 60% correct, and it depends ultimately on human beings to decide whether 60% is a good analysis or 90% is a bad analysis. So it all depends. Final decision is on human beings only. So this thing is very important. So let's now analyze our data. So okay, here it comes. Now why I like this data here? See here. This is let's just copy paste this thing down here again. Now, why I like this data? Because this data of advertising is more related with our profession type of. I saw the registration form. There are people from various colleges and persons from industry as well. And we both need advertising. Like we people in college advertises about our colleges. The company guys advertises about their products. And so there are three methods of advertising. One is TV, one is radio, one is newspaper. And through some surveys, our owners get this data. Just we are assuming that we get this data, whether where it is showing that how much ad was proposed in TV, in radio, newspaper, and how it affected the sales. So this is more related to our advertising profession type of thing. So I like this thing. So let's analyze this thing, and our task. Suppose our boss asked us to see whether this advertising in newspaper is affecting our sales, is boosting our sales or not. What is happening? There are three things: TV, radio, and newspaper. And what is happening? TV, radio, newspaper. Now my boss wants me to check that he is investing in newspaper ad, and whether not. So let's see how to check whether it is boosting our sales or not. Okay. So TV, radio, newspaper. So what is the first thing that we need to do? See here, by default, this 0, 1, 2, 3 on the extreme left side. This is not in our data. This is just the pandas notation to show that it is a row. This is 0, 1, 2, 3, 4. These are rows. And first thing we need to get rid of this thing. So how we will do this? What we will do, we saw here, there is one column. If I just shift tab here, if you see here, in shift tab, let me show you. It is written here. Yeah, see, this is index underscore column. It is integer by default. It is false. Now default it is none. So what I need to here, I need to write here index. Now what I need to do, I am using the index column as the first column. Index column, this is the first column. 0, 1, 2, 3, 4. I need to remove this thing. So what I am doing, I am assigning the index column to be 0th column. Let's run this. So now this thing is removed now. So here it is 1, 2, 3, 4, 5, 6. So now it is 200 rows, 4 columns. Now what is happening actually? This thing is just creating some confusion. What is this thing and what is this thing? So I just remove this. By default, it will occur every time in any data set, whatever data set you are using. This thing will come. This is pandas notation of zeros, of rows, and I need to get rid of this. So this is how you can do this. Now let's move on and see what we can do with our data to see. So what I am doing, first thing, now I'm starting with proper machine learning thing. So in machine learning, there are few things which you must know. One is feature and one is response. So let me write this thing here. I'm using Markdown here. Using Markdown, I can use the Jupyter coding editor as a writing pad also. So I need two things. One is feature and another thing is response. Okay. So feature and response. Now what is feature? Features, response is my output. Simply understand this thing. Response is my output and features are my input. So here in this case, I want to check sales. I want to check sales and my features are TV, radio and newspaper. My output is sales. So let's see how to separate the data into features and sales. So let me write a column here, feature underscore call, and this is equal to TV, TV, newspaper. So these are my feature columns. Again, this feature underscore call is a variable name. You can write it anything. but just I make it meaningful so that later when I read it, I understand what is this thing. So feature and response, first thing is feature. Feature is TV, radio and newspaper. And again, one more thing, this is not the most appropriate way to write the feature column. Actually, if suppose there are 10 columns, then it is not advisable and feasible to write 10 columns here. So in that case, you can use iLog uh, and slicing notation. You can use the slicing notation and the iLog to check which things you want in your feature column and which things you don't want to use in your feature column. So here I am using three columns. I have got only three columns here, so I can write straight away the three columns. Okay, moving on. Uh, Let me pass it into a variable x. Now x is equal to data and it is feature column. And if I print x, so this is the my x variable in which I have passed the feature column. So there are 200 rows and 3 columns. And again, you can, that's why I taught you some basic stuff there, because now we have to use everything here. Now I've got x dot shape here. These all things are necessary because when we choose the target or when we choose the response, then I need to have the matrix dimensions in correct order. Otherwise, it will throw error. So type of X is data frame. Okay, it's working. Everything is good. Moving on. Now I'll choose the target. So like 1 minute. Okay. So let's choose the target now or the response. So target equal to target is sales. One entity only, sales, and I pass it to a variable y. And this, okay, so this is target. So this is my target, 200 rows, 1 columns, and let's just print the shape also. 200 cross 1. So this is 200 cross 1 and this is 200 cross 3. Dimension should be same, so it's okay. And if I just print the type also, no issues. Type of y, so it is also data frame. So these are mandatory things which you should check. It is not necessary, but you should check before proceeding. Now, let me why I am using here capital X and small y, because in I'll be showing you machine learning stuff using scikit-learn, and there you must have heard the names training data set, testing data set. So actually this testing data set is a vector, single vector, and it is denoted as a small y. Whereas the training set, which is a combination of multiple columns, it is generally treated as a multi-dimensional matrix. It is written as capital X. Although you can use a small y, you can use a small x, you can there is no need to worry about this thing, but this is just a standard notation which everyone follows, so we are also following that. There is no problem in that. Okay, moving on. Now let me plot the relationship. So for plotting, what I'll do, I'll again use Seaborn. Now there are different plotting libraries like Matplotlib, Seaborn, Plotly. You can use Matplotlib also. I use Seaborn most of the time. Let's run this thing here. Import Seaborn as SNS. And this star here means that it is just trying to running this cell here. So we can wait for this thing. Okay. So matplotlib is building the font cache. This may take a moment. So it is just fetching the library details. Now it is done. So let's plot a pair plot, and let me show you SNS.pair plot, and just a minute. Okay. SNS.pair plot. Pair plot is a plot which gives the plotting in pairs, and it is a very good function to visualize what is going on. So let's see how to use this. So I'll write SNS.pair plot, and then the data set name data, and in X variable, so it is written as X VARS. What I need in X variable, I need these three things. So let's copy paste this directly. Control C and Control V, and then Y variable Y VRS equal to what I need, sales. So I can directly write sales here, and then just shift enter and see what happens. Okay. So if you see here, the first thing is getting blank. Then I have got some plotting here. Now, if you are using older version of pandas and anaconda, then you will see the data here also. But in this newer version, again, that's why I have worked on older and newer version, and that's why I chose you to show you this new version stuff here. This is not our problem. This is the problem of Seaborn library. Actually, Seaborn library, what it do, uh, here you see the axis. It is only taking from 0 to 1, where it is taking 0 and 0 to move on. Now, what is happening? In short, not going in deep technical thing, all accesses are not used here. So actually, Seaborn library, what it does, it look around for diagonal first and then works like that. Diagonal plot. Now here it is off diagonal plot, and that's why it is not showing. So what we will do, we will copy paste this thing here, Control C and Control V. And what we need to do, we need to pass a parameter here, diagonal kind equal to none. So I am just asking SNS or Seaborn library to don't check for diagonal kind, just check for everything. And when you run this, now you can see that your TV plot is also printed. So if you are using, again I'm saying, if you are using old pandas version, this problem won't occur. It will get printed like this only. But if you are using this new pandas, and obviously you have to use the new anaconda packages, so this thing can occur. So you have to mention this parameter also. Now let's just increase the size of this graph to visualize it more clearly. So let me copy paste this thing here. Control C, Control V. And now what I'll do, I will put some aspect ratio. I am just increasing the size of this graph so that it becomes more visible. Aspect 0.7 and height. Let me increase the height also. Height is equal to 7. So now this graph has become more visible, more clear to interpret. And now what you see, using this graph, we can see that the TV, as the price of ad increases in TV, the sales also boosted up. In radio also, it is like TV, much less. But in newspaper, it is just like distributed everywhere. And this thing, we can put one more thing here to check, and that is called uh, kind equal to reg. So it will just plot a line showing, let's see. Okay, so this is the boundary line actually. This boundary line shows that this problem is a good contender for regression analysis, because this is a very linear relation, and regression means actually a continuation, something in continuation. Now there are two types of things, classification and regression. You must have heard, or if you haven't heard, then just remember that classification means discrete values like 0, 1, 2, and regression means continuous values. So here, if you write kind equal to reg, it plots a line and it shows that this is a good contender to apply regression techniques. So let's try to apply something here now. Okay, so talking about linear regression, now I'm using linear regression. It is fast, it is highly interpretable, easy to understand, and no tuning is required here. By tuning, I mean parameters. There is no need to tune the parameters. Talking about consequences, this is a good linear regression is a good first time thing to learn, to dive into machine learning thing, but it is not very famous to predict accurate result, because its name is linear and it assumes that there is a linear relationship between feature and response. Fortunately for our data, this advertising data set, our response is linear. Okay, but linear regression assumes that there is a linear relationship between features and response. So if we talk about, let me write the general equation of linear regression. Uh, Linear regression. The general equation of linear regression is we write y is equal to b naught plus b1, so b1 x1 plus b2 x2 plus bn xn. Now, this is the general equation of linear regression in terms of statistics. B0 is a constant, or we can say intercept. And similarly, talking about B1, B1 is regression coefficient for x1. Regression coefficient for x1, or we can say this is the first feature. In simple language, this is the first feature, or in our data set, it is PV. So first feature is TV, second is radio, third is newspaper, and if there are more features, you can just add to that. Similarly, what is this thing? P2, X2, second feature, and so on. Okay, so this is the general linear equation form, linear regression form, and let's just write what is this thing in our case. So In our case, it is y equal to b0 is a constant or intersect. It will be as it is. We will just find it what it is, and then b1 is what it is. It is for us tb, and then b2 is x2 is radio, and that's b3 is newspaper. Okay, so this is for our data set. This is the linear regression form. Now I need to this b is called model coefficient, and these values are learned during model fitting step using least square criteria. So let's start with our prediction. Now let's start with prediction. So we have got features, we have got responses, and now it is time to just split our data. So what I will do from, sorry, I have turned on the tabs now. From sklearn, now I'm using scikit-learn library, which is very easy as a beginner, for a beginner to learn. So sklearn.model underscore selection. This is the library, and from this I need to import train test split function or method, train test split. So let's just wait for it. Okay, so I am using scikit-learn, which is a very famous library, and from sklearn.model underscore selection I need to import this method. This is train test split. Now how to use this method? I need to split my data now, and I'm just explaining why I need to split it. So y train and y test, and then I need to write this train test split bracket x comma y comma random state equal to 1. Okay, now what I'm doing, if you remember in Python, in tuples, there is a concept of tuple packing and unpacking. So what I'm doing here, I am unpacking these things into left side variables. I have got 4 variables: x train, x test, y train, y test. I have got features, I have got response earlier. X is TV, radio, newspaper, y is sales. So what I am doing, I am using my data set, I am splitting it into 2 halves. Now what is the need of splitting? Can we use unsplitted data? So tomorrow I'll show you how to use unsplitted data as well, and what is the need of splitting the data. The need of splitting a data is, suppose there are 100 numbers. For example, there are 100 numbers, and in that 100 numbers, there are many numbers repeated. Suppose 1 is repeated 10 times, 2 is repeated 20 times, and they are arranged in random orders. And I am training my model to learn what is 1, how to identify 1. So if I am not splitting my data, then I am just feeding my machine learning model with that entire 100 numbers, and there are 10 ones in it. My machine is learning from those 10 ones, and then at the time of testing, it is again testing if 1 is present in that list. If it has already learned from those 10 ones, then how it will fail to detect that it is 1? Because there are only 10 ones, machine has learned from those 10 ones, then every time machine will detect, okay, this is 1, this is 1. So that's why we split the data. That splitting can be in any ratio. Suppose if you want to train 70% data and then use that training to to detect from the test set. So by default, if you write like this, then the test size is 25% and training size is 75%, like that only. I don't remember the actual figure. But there is one more thing, that you can assign the test size by yourself, that I need 30% of my data to be test size and 70% of my data to be training size. So what happens now? My entire data set, it will be divided into two halves. One is 70% on which the machine will learn. Okay, this is one, this is one, this is one. Next is another 30% in which the machine will test what it has learned. Okay, it has learned in 70% that one looks like this, and then in 30% it will check for, okay, is there anything that looks like one, and then that is more accurate result actually. Talking about this variable random state, this number is nothing. You can write any number here. This just means that every time you rerun this cell, the output remains same. Otherwise, every time the output will change, and you will not figure out that whether it is right or wrong. So this is training and testing. Now let's check the size, because we have just split. So let's check it. X train dot shape. Let's check this thing. X train dot shape print X test dot shape. I'm just checking the shape of all these values. Print by train dot shape and print by test dot shape. Now let's run this. So now you'll see uh, the data which was earlier 200 cross 3 training and testing set has been splitted. Now it is 140 columns used for training set and 60 columns are used for testing set. Okay, so this is the use of splitting. If tomorrow I'll show you an example. If you don't split, then also the things will work. There is no problem. And this concept of splitting the data is called testing accuracy. This is called testing accuracy. And if you don't split your data, if you just train and test the model on entire data set, then it is called training accuracy. Okay. Now let's use scikit-learn from sklearn. Again, I need to import scikit-learn linear regression here. From sklearn dot model linear model import linear regression. Again, just take care of case sensitivity. L is capital, R is capital. So from sklearn.linear underscore model import linear regression, enter. And now I have to create instance, because like I was using pandas as PD, so that I don't need to write every time pandas. So similarly, every time I don't need to write linear regression, so let's create instant. Again, you can use any name. I'm using linreg, linreg. It will let me remember that, okay, this is linear regression. So I have created an instance here, linear regression linreg, and then now we will what we'll do, we'll train our model. So for training, what we use, X train and Y train. We use these two using method called fit. So linear reg dot fit, and then X train, comma Y train. So these two training functions are fitted into my linear regression model. And if I run this, nothing will happen. It will just demonstrate this. Now I will print the intercept and coefficients. What are these? These things. B0, B1, B2, B3. So let's see how to use this thing. Print len reg, again this is linear regression instance, dot intercept and a single underscore. And similarly, control C, control V, this is COEFF, sorry, single F. So linreg dot coefficient, linreg dot intercept, let's run this thing. So now this value is B naught. As per the linear regression standard equation, this is B naught, the constant or intercept, and these are the coefficients of TV, radio, and newspaper. And we can just map these things just to look better. So I have got the feature column, which is TV, radio, and newspaper, and I have got this lin reg coefficient, single underscore. So this is feature column TV, radio, newspaper, and they are corresponding to their coefficients also. Okay, so this is feature column linear regression interpreting this. So now what we can analyze that just B0, we can write the numbers here instead of now B1, B2, B3 and B0. We can use these numbers to fit in our linear regression theoretical equation. Now what this thing tells, this thing is telling that for a given amount of radio and newspaper ad spending, 1 unit increase in TV ad spending is associated with 0.046 unit increase in sales. Means if I am investing 1 unit in TV ad, then my sales is boosting up by 0.04% every time. Or you can say that in TV ads, if I am spending 1000 rupees, then 46.9 percent, 0.9% or unit amount of sales is increasing. Similarly, if I am spending 1 unit in radio, then 17.6 unit of sales is increasing in radio ad. With the help of newspaper ad, you can see if I and now at this point of time you can analyze that if I am spending 1 rupee in news ad, then only 0.001% sales is boosting up, and this is not a very good thing in terms of newspaper. Let's check the error. Making predictions, time to make prediction. So now what I have done, I have trained my model. Now I need to make prediction. Now what is happening? My machine, it has learned. I have fed the machine with the features and responses. It has learned everything. Now it's time of machine to predict. So y predict equal to lin red and lin red dot predict. So it will predict, these are functions, linreg dot predict, and it will predict from x test. So let's print the error. From sklearn import, again there is a from library matrix. Now what I am doing, I am just checking the error. Print numpy, so we have used numpy as np dot square root. Now what I am doing, I am checking for mean square error. So square root of matrix dot mean square error. mean square error, and here I need to print y test and y predicted. Y test and y predict. Now, if you see, this y test is the um, y test is the actual output that I need to check, and y predicted is the predicted result. And what this line is doing, I am checking that comparing these two. This is the predicted output, this is the actual output. And what is the value of error? Because this is predicted, this is, you can say that this is practical, this is observed, and this is the ideal case. And I need to find out the mean square error between these two. If this error is very less, then we can say that both the values are in there is not much difference in these two values. Let's run this. So I'm getting a value of 1.388. Okay, can I print this y test also? Let's check this thing. Okay, so if you see, this is print y test. This is the actual result. This is the actual result. And now let's print the y predict, which my machine has predicted. And if you compare these two values, the first one is 23.8. My machine has predicted it 21.66. The second value is 16.6 and my machine has predicted is 16.4, almost equal. 9.5, 14.8, 17.6. Just remember this so that you can compare this. So here it is 9, it was 9, here it is 17, it is 17, it is 18. So this is what my machine is predicting. After learning from the training data, my machine hasn't touched this test data. Now it is, this is the test data, and what the machine has predicted, it is comparing the values with the test data. And I am calculating the mean square error, which should be very minimum. So here it is coming 1.3888574, and you can just compare here and see that almost almost equal values are also there, and very few deviations are there. 21, 23, it is acceptable for a machine type of thing. Let's check one more thing. Print metrics dot accuracy score. Score of y test comma y predict. Some error. Continuous is not supported. Okay, so we will see this in some classification model. Because this is regression model, so continuous is not supported. Actually, accuracy score is something which is more readily used in some classification data type. So tomorrow we'll see this. Now let's check one more thing. Let's check. So what is happening here? This thing is showing that there is a mean square error of 1.388, which is very small. Now let's do one more thing. Let's remove the newspaper from our feature column. Let's remove the newspaper. Only I need to take into account TV and radio. TV and radio. And let's just run this thing. Now everything what we did, we are just again using this thing. But now I am just removing the newspaper column and doing the exact thing that I did earlier. Now here if you see, I can directly pass the sales column Earlier I had written it target equal to then data target. So if you have got a single column, then you can write it using dot notation. If there are more than one column, then it is always advisable to pass it in a list and then use like this. Okay, and then just let's copy paste the train test line to avoid some typing. This one. Let's see. Control V and min drag dot fit. Again in fit I need X train and Y train. X train, Y train, and then I need prediction. Y pred equal to min drag dot predict X test, and then I need to print the error. Again, let's copy paste this. And let's run this. Okay. Linear thread. Where it is? Drag. What is the relation of vectors? Okay, wait a minute. Just run few cells again. This can happen. There is no problem. Where it is that linear reg? This one. Let's run this thing again. Okay. What is happening? It has taken the feature column. Now it has removed the newspaper. Let me just change the variable name. I think now it will. Let's just run from the beginning. It happens at some time because it was my mistake. I just overwrite the name actually. Check column. Okay. So it was just my mistake. I override the variable name and lim reg dot fit x train y train. Lim reg y predict equal to lim reg dot. That looks okay. So now this is 1.3837 and earlier it was 1.388. So what does it signifies? That in presence of newspaper and in absence of newspaper, the result is same. It means that the ad given in newspaper has no effect on the sales boosting. So I can remove the newspaper I can ask my boss that don't invest for ads in newspaper. It is not affecting in boosting up the sales here, and I can save some money for the company. So this is the actual job of data scientist. This is the one job of data scientist. And what is the final conclusion here? Let's just write the final conclusion here. The RMSE decreased. The RMSE, that is root mean square error, decreased when we remove newspaper from the model. And error is something which we want minimum. So here, this is also error, root mean square error. It is minimum now. It is decreased just a bit. And in data analysis and data science, the percent percentage weightage is also important. So it is 383. Earlier it was 388. So it reduces significantly, you can say. So it means that lower number of RMSE is better because this is error and we want minimum error. The newspaper feature is not so useful and can be removed from this model. So this is how you use data analysis, and this is the job of data scientists in different companies to analyze data. This is how you actually analyze the data. So if there is any question, please let me know. You can type it in WhatsApp group, or you can unmute yourself and ask here. If there is anything, please let me know.
See, Google Colab is also available. Then which is better, Google Colab to work, Google Colab or ये Jupyter Notebook?
Ma'am, Google Colab is available, and I have worked on Google Colab also. Both are useful. Both have their advantages. In Google Colab, I think you always need internet connection. I think so. But the files are automatically saved in your Google Drive. So it is accessible every time from any location. In this case, you need this setup, you need to install this everywhere. So whatever is feasible to you, you can use. There is no problem. I haven't installed anything in Google Colab. Installed means like if I need to install any new library. So I haven't installed it, but it is also Jupyter file .ipynb notation, and I expect that there also the things are available. Whatever you feel like, you can install it.
One more thing, in one course from IIT Bombay, they are asking to install Canopy, and the commands are totally different.
Ma'am, actually there are numerous number of tools. There are numerous number of tools.
Okay,
and
but but if we are doing or if we are mastering in one tool, and if we want to do course like same Python, we are doing course, but different platforms are there, then commands are different, then it will be very difficult for us to get mastery in Python. Because commands are different. In Canopy, commands are totally different for plotting. Then it will be very confusing. It will be very confusing statement.
Actually, ma'am, it depends on us which tool we want to display. Like I am using Seaborn, I am using Matplotlib also, and one of my student was asking me to use that Plotly. So actually, these tools are for data visualization. how better you want to visualize your data. If your job is satisfied by simple visualization, you don't need to use heavy tools. Like you are using Canopy, and IIT Bombay was suggesting that you can use that Canopy, because here, see, if you see this entire set, if you see this entire presentation, uh, I don't think if you don't know Python, you can't do here anything. In fact, not a single command of Python was used here. If you closely see this entire lecture, not a single command of Python was used. This entire command is of pandas. The concept of Pythons are used, like tuples and all that. And when you do more analysis, when you get involved in deep analysis of data, then Python is actually used. So if you are using any tool to visualize, obviously you have to master it, but you don't need to learn every tool. That is my personal opinion. You don't need to learn every visualizing tool. There are numerous tools available. Just take one tool, learn it from start to end. If you are satisfied with its visualization appealing techniques, then obviously you don't need to jump to another tool and look for Plotly and Canopy. Because what happens, these tools have got so many features, and they are also getting updated like another tools. So it solely depends on us. And if your boss need to learn this thing, or if you are if you are doing post graduation, you are doing doctorates under someone, and that person wants you to learn something, then you don't have got any choice actually. So this is the thing.
Okay.
For me, I only suggest that, okay, take one tool, learn it by heart, practice it. If it is giving sufficient accurate results, then you don't need to jump to another tool, unless there is a much need that you need. There is a die-hard need that, okay, I need to learn this. So there are many tools available. Even I said that there are many tools like pandas, there is R. uh, Data statistics is more preferred on R, because it is a more statistical type of features it has got. But I learned this. I haven't practiced on R much. I know about basic about R, but I learned this, so I am practicing on this. And if my work, which I could have done on R, is being done here also, then why I need to learn something else? So, I'll send the CSV file, this advertising CSV file, in the WhatsApp group after this presentation. And I hope I was clear about telling things. Tomorrow, I'll move on from this thing again. There are a few more slides here. Tomorrow we'll continue this thing and see. And tomorrow also I am going to use one more data set from basic to advanced. And tomorrow I'll show you two important concepts, how to use certain features of my data set where we fail, and wrong predictions can be done. So for the time being, I think it's enough for today. Um, if there is any doubt, you can WhatsApp me also personally. You can ask me in the group, and I'll provide this set here. Any doubts? Anything you don't understand? Okay, shall we close? Okay, I'll provide the video recording also. So thank you. We can end this meeting here, and we'll meet again tomorrow at 11 o'clock with more machine learning practice. And I hope it will benefit you. So thank you.